Hello everybody, my name is Joshua,
My name's Talib.
and this is Potsticker, a winning project for SpartaHack 11, an AI-powered honeypot. The motivation behind us building a Potsticker is that modern honeypots are easy to evade. There are multiple known techniques, and we will not know what an attacker will do after they get in the system, or what sort of information they are after, or how they react to different changes within the system. The difference for Potsticker is that Potsticker uses AI to target multiple different stages of attack, creates a personalized environment for every attacker, logs every step, and is completely automated without requiring human intervention. Potsticker is built on top of Free Willy and the Wi-Fi Orca module, and we chose this technology because Free Willy enables scripting access points and allows for hot swappable configurations, meaning that we can change access point information, passwords, authentication types while the access point is running. And all of the commands were simple and accessible through the serial port of the Free Willy. The two types of honeypots we created were the Wi-Fi honeypot and the Flask web honeypot. The Wi-Fi honeypot detected deauthorization and pin brute force attacks through sniffing packets on the network, sent back spoofed packets to the attacker, and reinitialized the access point according to the attack type um, in order to fool the attackers. And in the future, we would like to write customized access point firmware supporting different Wi-Fi types and encryption methods for the ESP32 chip on the Free Willy Orca device. And for our Flask web server, we wrote a web server that detects dir busting and endpoint scanning attempts with log instructions and inject the template as well as the logs into an AI LLM to generate a new Flask server with exposed endpoints and vulnerabilities to keep the attackers guessing, and this process would repeat every time a certain amount of logs were generated.
So now let's get into a brief demo of how this works. Our web interface allows a selection of a network and interface to log, which we can set up right here. We're also able to select the type of Wi-Fi attacks we want to log, either deauthorization, WPS detections, or even both. So for this, we'll select all detection. Whenever the web interface is spun up initially, our Free Willy device will create an access point. In this case, it's created the code 87 access point, which I'm connected to. Then we can run this Python file, which will simulate an attack. And attacks, as you can see, are logged in the attack log section on the interface. And then, when our system detects a attack, the Free Willy will then go ahead and create another access point. In this case, it's the fake edge room. And then we will also be automatically connected onto it after a short period of time. As for the web honeypot, we're able to generate a Flash server by clicking this button, and then logs are collected below. Every time an attacker enters an endpoint or goes to an endpoint that may not exist, it will get logged down here. For example, /admin will take us to here, but if we try to go to, say, a endpoint that doesn't exist, then the resource is not found. After a little while, the log will collect that, and after a little bit more time, that endpoint will be generated, and this essentially keeps attackers constantly busy. As you can see, the log has appeared, but yeah.